Welcome back to our Math 171 video series. In this video, we'll learn how to deal with intervals on graphs, both increasing and decreasing intervals, as well as dealing with inequalities. Our first question deals with increasing and decreasing intervals. We are asked, to two decimal places, where are the local minimums and local maximums? To find a local minimum, we're going to look for the valleys on the graph. That is, the places where the graph reaches a minimum, but then begins going back upward again. You might notice that on the right side of the graph, at the position that I'm boxing in red, the graph appears to drop to a minimum and then come back up. This is called a local minimum. You may also see a point that is similar to that, except for it looks like we're reaching a maximum and then coming back down. I'm boxing that in green. That would be our local maximum. So keep in mind the local minimums look like valleys and the local maximums look like peaks. To answer what the local minimum is, we will use two decimal places because the directions say so. So that point will be these coordinates that I'm underlining now. That's 1.36 if we round, comma, negative 1.73, since we have to round that up. For our local maximum, we'll have an x value of negative 2.69, again rounding to two decimal places, and a y value of 1.05 if we round that to two decimal places. Make sure that you are rounding to exactly the number of decimal places they ask you to in the question. Now to find the increasing and decreasing intervals, we're going to draw another picture with a number line. On that number line, we are going to mark our local mins or local maxes. You may have more than one local min or more than one local max on your graph if you have a more complicated one. That's all right, just make sure you mark all of them. Based on the location of the local mins and maxes, we are going to split that number line up into regions. Our local max was on the left side at negative 2.69, and we'll mark that. We'll also mark the local minimum, which is at 1.36. Notice that we are not writing the y values, we're only writing x values when we answer increasing or decreasing. We'll also place negative infinity and positive infinity on our number line. The part of the graph that is to the left of negative 2.69 we'll label as region A, and we'll mark that on the graph as well. The part in the middle between the local max and the local min we'll label as region B, and we'll label that on the graph as well. And then the part to the right of 1.36 we'll label as region C on the graph. Now, when we are deciding whether the graph is increasing or decreasing, we will always read left to right. So now the part of the line that I am drawing over in green, if we read it from left to right, it looks like the y value is going upward. If it's going upward, that is increasing. Therefore, we'll say region A is increasing. Now, if we do the same thing with region B, this part I'm drawing in green now, as we go left to right, it looks like we're headed mostly downward. We call that decreasing. Then for region C, starting from the beginning of region C, we're going to see that our graph goes upward, that I'm drawing in green now. That's going upward, we'll say that's increasing. Therefore, we'll say our decreasing part of the graph is region B. And our increasing regions are A and C. To place this in proper interval notation, we'll notice that region B goes from negative 2.69 to 1.36. We will place those endpoints on the left and right in our interval notation because that denotes region B. Also note that when we do increasing and decreasing intervals, we will always be using parentheses, never square brackets. For our increasing intervals, Region A goes from negative infinity to negative 2.69. Then we'll put the letter U for union, showing that there is another region coming. The other increasing region is region C, which goes from 1.36 to infinity. So now we've identified where the increasing and decreasing intervals are.